this video, we're going to take a look at finding the point of intersection between a linear graph and a non-linear graph. So when I look at these two equations here, in my head, I'm able to picture what they look like graphically. And when I see that blue equation here, x squared plus y squared is equal to 5, I actually see a circle. And it's a circle with the center of 0, 0 and a radius of root 5. So as you do more of the maths course, you'll learn how to interpret these equations, but for now, you can take it as the equation. The other equation in pink here is a line, and lines can be written in the format ax plus by plus c, or they could be written in the form y is equal to mx plus c. And you should know from junior cert how to interpret those graphs and to be able to picture them in your head from the equation. So what we're talking about here is a circle meeting a line, and we're trying to figure out where did they meet and how many times did they meet. Is it more than once? And we can do that by using simultaneous equations. So whenever you're asked to find a point of intersection, whether that is in relation to a circle and a line and a line, or a graph and a line, point of intersections can always be found by using the tool of simultaneous equations. So how do we solve a simultaneous equation where one of the equations is not a linear one? The trick is to take the linear equation, which we have is x minus y plus 1 is equal to 0, and rearrange that so that you either get x equals everything else or you get y equals everything else. And it does not matter which one you choose. You just pick one of them and you rearrange the equation. So if I'm to pick this one and rearrange it so that I've got x is equal to, I'm going to add y to both sides and I'm going to subtract 1 from both sides. And now I haven't changed the value of the equation itself. All I have done is rearranged it so that it's in a format that suits me better. What I can do with that now is I can take my original circle equation here, and instead of saying x, I can actually replace it with what I know the value of x to be from the linear graph. So I'm going to do a simultaneous equation by substitution is what we would call this. So I'm going to have y minus 1 squared plus y squared here is equal to 5. I'm going to square that out, and I'm going to be super careful squaring that out so that I don't forget anything. It's going to be the first one squared, the product, which is going to be minus y by 2. So it becomes minus 2y, and square the last one, which is going to give us plus 1. I can then fill in the rest of it here. So plus y squared is equal to 5. And I'm just going to tidy that up. So then I'm going to get y squared, and y squared gives me 2y squared minus 2y plus 1 is equal to 5. Now, that's lining up to be a quadratic. And if I want to solve a quadratic, I need to have everything to the one side and let it equal to 0. So I'm going to have 2y squared minus 2y. Bring the 5 over, or subtract 5 from both sides, and you're going to get minus 4 is equal to 0. Before I try to solve that, I would actually make it easier on myself by looking for the common factor. And there is a common factor here, which is 2. Every one of those numbers could be divided by 2. And if I do that, I'm going to get a much nicer question, which is y squared minus y minus 2 is equal to 0. So then what we're going to do here is factorize it. We're going to get our y and our y. We're going to get our 2 and 1. Because this is a minus, the signs here will be opposite signs. And because this is a minus, I'm going to give the minus to the 2. Then what I can do to check that that's correct is I could multiply out by out and in by in. So I'll get minus 2y plus 1y. And if that adds to give me minus y, so plus 1y minus 2y, it does, I've got the right factors, so I know I'm on the right track. So it's a quick check for ourselves to make sure we've got the right ones. That then is two things multiplied by each other to give us 0. The only way in the universe that you could multiply two things and get 0 is if one or both of those things are equal to 0. And then I can go from here and say y plus 1 is 0. That must mean that y is equal to minus 1. Y minus 2 is equal to 0. So that must mean that y is equal to 2. Now, I've just figured out what y is. And there's two y values. And that tells me if there's two y values or two y coordinates, that the graph and the circle, they're actually going to intersect at two places. So there's our circle, and our line might be going through it like that. So there's your 2 points of intersection. So we're not finished yet though. We still have to figure out what the value of x is, and we have a way of calculating that rather quickly. If we know that x is equal to y minus 1, and now we know what y is, we can just substitute y in. So x is equal to y minus 1. Well, now x is equal to, instead of y, I can write minus 1, and then our minus 1. So x is actually equal to minus 2. And that, I could report both of those as a coordinate, and the coordinate is going to be minus 2 minus 1. The same thing here, I can go again and do the exact same stuff with this side, with our value for y is equal to 2. And I'm going to have that x is equal to, instead of y, I can write 2 minus 1. And then x is equal to 2 minus 1, which is 1. And then I've got my x coordinate and my y coordinate, so I get 1, 2. So there's the two coordinates where the line and the circle will meet each other.